So far, we discussed about the lists. Let's explore the another data structure that is called a tuple. Now, a tuple is a collection which is ordered and unchangeable. In Python, tuples are written with round brackets. Tuples are sequences just like the lists. The difference between tuple and a list are that the tuples cannot be changed unlike lists. We can create the list, we can insert element in the list, we can override the existing element in the list, but all these operations are prohibited in the tuples. Let's just start by defining the tuple. Opening our Python notebook. Now, if you remember correctly, then in the previous video, we created the list, an empty list, by assigning a value to square brackets. But when you want to create a tuple, you need to use the round brackets. When you use the round brackets, you are creating an empty tuple. If I try to print the type of the A, it shows me class tuple. As I already mentioned, that we cannot add or delete anything once a tuple is created. So if I try to insert anything in a tuple A, then let's see what will happen. I write A of 0 equals hello. If I try to compile it, we get tuple object does not support item assignment. It's because we cannot do such operations. Now let's just create another tuple with some predefined values. We are about to create a tuple A equals, and we are going to use again the round brackets, and then we can define whatever data we want to use. There are no restriction on the data types that you can use in the tuple. I can use the string, the integer, and the float. It has been compiled. Now if I print A, then you can see it shows me whole ranges of values. Now its operations are as similar as of the lists. It's time to discuss some predefined function for the tuples. So the first thing that we have for accessing an element in a tuple is definitely an index. Same rules applies here. The index starts from the 0. You can access the element just by writing its index. But you cannot override any existing value. If I try to override 12 with 13, then it gives me an error. It does not support item assignment. It's because it's immutable in nature. Now, the next thing is the negative indexing. What if we want to fetch the last index value of the tuple? So we need to write -1, and it gives me the last value. Next thing we have is range. For range, you can use different combinations. Like if I want to print from the very beginning up till some point, then I had to keep my first value as empty, and then I need to define the number up to which I want to access the value. Let's say 5, no, 3. If I do that, it shows me first 3. If I did that, it shows me from the index 3 up till the end. And I can slice it in between 2 and 4. So now you can see all the variations that we can use in the range function. Same applies for the length function as well. To find the length, you just need to use the length function and then pass in your tuple. Then you can see the length. Talking about the delete function. Now, as you have already seen that you cannot insert or update the current values that are already inside the tuple. But you can delete the entire tuple. I can delete the entire tuple, and if I try to print A, it shows A is not defined. So you cannot override the existing values, but you can delete the entire tuple. Let's discuss our third data structure, that is a set. A set is a collection which is unordered and unindexed. This data structure is used when you don't want any data redundancy in your system. If you want to prevent your system to get the duplicate values, then you are more likely to use the sets. To create a set, you need to use the curly braces. So you need to assign a variable and then use the curly braces, and then you need to write up your data. Now I am going to show you how it is going to remove the data redundancy. I am going to write hello again, and then I'm going to compile it. Now if I print A, then you can see it only shows 4. It's because the hello has been repeated twice. But if I changed the H to the uppercase and then I run it, then it shows me 5 elements. So in this way, the set has the capability to remove the data redundancy. Let's discuss some useful inbuilt functions of the set. The first function that we had is the length function. So to find the length, you can use len and then pass in your set. You can see the length. The next thing that we had is adding a set to the another set. So it's pretty much like the mathematical union. So in order to do that, you need to create two sets. So I am going to create two sets and I am going to assign them a value. And then I have to choose which set I want to create as a superset. Now in this case, I am going to assign A as my superset. So A dot union, and then I pass in B. If I hit enter, now you can see that these two sets are combined. But still, as you can see that we have 16 here and 16 here, but we only see 16 once. So it's because it has the tendency to remove the duplicate elements. The next thing that we had is the intersection. What if I want to fetch out the elements that are present in both the sets? So to do that, we need to use the intersection operator. So what we need to do is just A dot intersection, and then we provide this B. If I did that, and you can see the intersection, it's only the 16 value that is occurring in both the sets. So you can get the intersection of these two. Now to remove an element from a set, you can use the pop operator. So I am going to use A dot pop. If I did that, so and now if I print A, now you can see one of the hello has been removed because in A we have two hellos. So last of the element is removed. So far we discussed the three different data structures that are widely used in the Python: the list, the tuple, and the sets. If you want to store a huge number of data values and you want to simultaneously process them, then you specifically need to use the list. But if you have already processed the data and you don't want the data to be changed, like declaring your result or declaring your grades, then you must use tuple because they cannot be overridden. And then come the set. We use the set when we want only the known duplicate elements to reside inside the data, then only we use the set.